Okay, in this video we're going to continue using the LCD screen. Remember on class last time we used this code to determine the I2C address for the LCD screen, and we got that to be 0x27. And so we're actually just going to start here with the same program here. We don't really need to do anything different. We still just are going to have the I2C master. There's no other components that we're going to bring in here, but we are going to have to bring in some additional things here to the program. So first we need to go to Blackboard, and then of course you would log in. And then go to the CPE class. And then if you scroll down, I've got an LCD I2C API and LCD I2 API.h. So I'm going to save these, and you can just do save link as, and it's saving as a C file, but we have to save it in a particular location. So you want to save it wherever you are actually editing the document here. And I forgot where I saved mine as, so let me see here. It's on the D drive. That's right, I'm not saving it on my solid state drive. So save it on my D drive. It's not there. Documents. PSOC Creator. Workspace 2. Okay, so I'm finally down into it, but we have to make sure we save it in the correct location. If you save it here, it's not going to work. You have to save the C file in the project here that you want to use it for. So we're wanting to use it for, in this case, I just called it design01. You know you're in the right one as long as you're in the, you see this main.c file here for the one that you're currently working on. Now you have to save these files in that directory. So I'm going to save those files. Technically there's other ways you can do it by changing path names as far as what the compiler is going to look for, but for this case I think it's just easier to save them in the directory of the project. Okay, and so I'm going to save the H file as well. Now I'm going to go back to PSOC and I'm going to go in here because I need to add those functions in here. So I'm going to add an existing item, and I've got to go and navigate again towards where I was. Documents. Workspace 2. And then I need to add in this L2 I2C API, and then I have to do the same thing for the C file. Now these are now added to the project so we can use them, but before we can really use them we have to go into the main C file here and include the LCD I2C API.h. That will give me access to the functions that are in this API. So let's go ahead and look at this header a little bit. So I wrote this one last year in February, version 1.1, because I've had to update some things. There's still, I think, a few things that are incorrect that I still need to update, but what we're going to use it for is perfectly fine. You can see all of my macros that are being defined here. There's quite a bit. We don't really need to do that. What we really need to look at here is the API function. So there's a lot of API functions here. A couple of the ones that we're going to be using is this one here. We have to initialize it first. Then the start. We'll use clear, home, set cursor, and I believe we'll do the print command as well. So those are the main ones we're going to look at. But to get an idea of what they do, that's why you can go into the C file here, because I give a brief of what all of this stuff is. So you notice how much documentation I've written here. And when we look at the init here, it says sets global variables so the device can be initialized. This function must be called first, and then it gives the usage. And remember I said it used to be the address was 0x3f. Well, it's not 3f, it's 27 like we discovered the other day. And then it's 16 columns, 2 rows, and then the default character size is just 0. And then we can call the initialize function because that gets called first. I guess I didn't write briefs for every single one of these. But then there's the LCD start, which again we will use as well. So let's get back here and go ahead, and I don't know how long this video is going to be. I'm not going to necessarily pause it and make a couple videos. I'm just going to make one video that does this whole thing here. So what I'm going to do here, first off, I'm going to delete some of this code here because I already know what the address is here. And we're not going to loop this right now. We're just going to go ahead and see if we can get some things printed to the LCD screen. Okay, so let's first just do the we have to, let me go back to my LCD I2C init. So once I start typing in, because I've included the header file, it will autocomplete for me. And then it'll tell me what I need to do is the address, so 0x27 is my address, number of columns, which is 16, number of rows, which is 2, default character size, which is 0. And that's just the number of pixel heights on this particular LCD screen. And then LCD underscore start. Because we have to start it just like anything else. Then let's just go ahead and see if I can print something and see what happens. So let's go LCD print. And now it's wanting a character word thing here. So we want a character array, but you can go ahead and put in here, let's just do hello. Is that, no. And let's just go ahead and program this and see what happens here. I might have done this wrong, because I'm trying to think here. Is it quotes that you do here? Yeah, no, it is the exclamation. Oh, and it did work. You have to adjust your, I can see it on my screen now. You have to make sure and adjust your contrast here. My contrast was turned up way too much. So if you might be seeing solid white dots, and that's because that, like, it might look like it's just completely white, and that's because the contrast is turned up too high. So if you just turn your contrast down a little bit, you'll be able to see the word hello. Very exciting. Okay, well, let's play around with a few of these other commands here. If I were to do LCD print, and then if I were to do LCD print again, and say Dave, it's going to give me 2 warnings here. Oh, because I have these undeclared variables here. So let me just recompile it here. And mine's not showing anything here. It's showing me the hello, but it's not showing me the Dave. Well, let's try this again here. Let's see what happens when we do that. Oh, I'll tell you why mine wasn't working. I accidentally managed to pull out the clock line here. So I managed to pull one of my wires out, which is why mine wasn't working. And I pulled out the I squared C clock line. So there we go. Yeah, pull out one of the wires on the LCD screen, it doesn't work, so shockingly. And so now it's hello Dave. But I did that on purpose because notice there's no space between those words. So now you can actually go ahead and put in here, you could put a space here, and it does recognize that as a space. And so if we program it, it'll put a space there. But let's just go ahead and do something like this. This is to see what happens. And you'll notice it says hello Dave this, and then that's it. Because this LCD screen and the way this API is written, it's not written in a very, what I would call, intelligent fashion. It's not like a word processing thing where it's just going to automatically go to the next line. You have to tell it where you want it to be. Now I'm going to also do one thing here. Let's put in a delay here so we can start over on some things, because I don't want to delete this here. So let's do a delay of a second. And then let's do an LCD clear and see what happens. Well, displayed it for a second and then cleared it. Alright, so then let's see what happens if I try to print again. I'm just going to print the word test. And we see that it tests. Because when you clear, it puts you also back in the home position. Now, let's talk about if you were wanting to, for instance, display, like for instance, maybe a temperature. And you were wanting to put the temperature on the top and like put the temperature and then put the actual, like the word temperature on the first line and then the actual temperature data on the second line. How would you get that? Well, first off, one thing you can do here is let's go ahead and do another, well, let's just leave this here as test. But before we do this, let's go ahead and try something here. I'm going to do LCD set cursor, and then we set the column first. So I'm going to go ahead and set column 1 and row 1. And I'm going to do that on purpose because we have to be careful when we think about this with programming. Some of you probably already know what's going to happen here. Wait, it put it in the second row and in the second column. But remember, with computers, what do we start with indexing? We start with 0. So if you really want to be in the first row, first column, that's 0, 0. So if I want to be in the first row, I would actually have column 1. This is still going to be the second spot over, but row 0. And then we can see that, yeah, it puts it back in row 1. Or maybe we should just start calling it row 0. Okay, so next thing we probably would want to be interested in is, what if I want to put in an actual, for instance, I'm going to just put in an integer here, and I'm going to say int data equals 27, just for kicks. And let's say I want to print that 27 there. If I do LCD print data, first off, it gives me a warning. It says incompatible integer to pointer conversion passing int parameter to a type char. So if you try to compile this, it will compile, but it doesn't give you anything else out, because we need a character. So we need to figure out a way to convert 27 into a character. Alright, so as I said, we have to figure out how to convert this to a string or to a character. So what we're going to first do here is we need to include another library, and it's stdio, which is standard input output library. And then I need to create another variable here. I'll call this sdata, and I need to create it such that it's big enough to contain the thing that I'm converting. So I know I'm converting 2 digits in this case, so I'm just going to make it a character array that's size 2. Okay, so I'm going to erase this command here. And then what you have to do here is you have to use a command that's called sprintf, and then we have to send it the character array. I believe I want to do this as what do I want to do here? I'm going to pause here for a second pause the video because I needed, well actually I'll just pull it back open here. So it's the string, yeah, okay. I always forget the format for this one. So it's the string we want to store it in. So we want to store it in sdata. And then I think I might be doing the wrong thing here. Constant character restrict. Well, I'm going to pause this here again because I think I might be using the wrong command. No, I was actually correct. I was just reading Cypress documentation. So what we want to do here to convert this to a string is we do sprintf, and then we put sdata. That's the character array we're going to store it in. %d means that it's an integer type. I know it sounds weird. And then you have to put what it is that you're going to be converting here, and that's the data. That's storing the information. Okay, so then what we can do is we can do an LCD print of sdata because it's a character array. And let's go ahead and put a space after test. Compile this and see what happens. Yeah, and you see you get test 27. Okay, so we can now do that as far as converting data, as far as converting numbers to data or to character arrays. We also might have decimal numbers that we need to convert, which can be a little bit more tricky. So let's look at that. So we're going to go ahead and put another thing up here, as we're going to say float data2 is equal to 3.1415. And then we're going to do char sdata2, and we're going to go ahead and put in, I'll just make sure we get it big enough, character array of 7. I don't think I needed that big, but you can always make it bigger than what you need just to make sure you have all the space there. Okay, so then what do we do here? Well, first I'm going to go ahead and do the LCD set cursor, because I'm going to put this on the second row. So column 0, row 1. Then I'm going to do my sprintf, and then I'm going to do my sdata2. This time, because it's floating point, we do %f, and this would be data2. And then we'll do LCD print sdata 2. Okay, so let's compile this again. And we actually get nothing coming out here. And that's because for some reason it should work, but for some reason the psoc command for this does not work properly. So we're going to have to come up with a workaround. Because if you look on your screen, you still see test 27. But there is a way to work around this. It's not the most convenient way, but let's show you how you can do that. And then that will end the video. So if you're having to do decimal numbers, this is what you're going to have to do to kind of get around it. So first off, you're going to need to know what kind of decimal numbers we have here. So first I'm going to just cast this as an int. Thinking just a second here. I want to cast as an int. Yeah. So I'm going to cast it as an int first. So I'm going to say first off here, I'll just overwrite data is equal to, I'm going to cast this as an int, and I'm going to say data 2. And then I'm going to just go ahead and compile this at every step to see what we get, so we can see how we're making progress here. Okay, so I've got the 3 now. Great. So now I'm going to LCD print the decimal point. So compile again. It's saying I'm not using sdata2, which is fine. And you can see I've got test 27 3 point. Okay, now we have to get that decimal number into an integer. Well, it's a little sneaky what you can do here. So I'm going to, I know I'm not got very good variable names here, but what I'm going to do here is I'm going to say I'm going to put another float here, and I'm going to call this decimal. And so I'm going to say the decimal is equal to data 2 minus data. And so that's going to give me 0.1415. And then I'm going to say decimal is equal to decimal times 10, 100, 1,000, 10,000. And then I'm going to do another sprintf, and I'll do sdata2, comma, %d, comma, decimal. And it's giving me an error here, a warning here. %f. Oh, because I have this as a float. Let's cast this as an int. That's all we have to do. And then we do LCD print sdata2. And I got 3.1415. So it's a little tricky with the decimal things here. Now, if you can figure out a way to not have to do this and find a function in PSOC that will take a floating point and convert it to string in one go, I will give you some bonus points because I have been unable to find that. But this is how you can play a little bit with the LCD screen. And of course you can do other things. There's other commands you can play with. For instance, you can do LCD blink on and just compile it and see what happens. And you can see the cursor now is blinking. So there's other things you can do with this as well and other functions you can play with. But this is the main gist of how it will work and how to get things to print to the LCD screen. So the key things you want to remember here to print to the LCD screen is first you have to start your I2C, then you have to initialize it with the proper address that we discovered in the course yesterday or the other day. Then you actually still have to start the LCD screen, and then you can just do these print commands and you can print strings, but remembering that it doesn't do any kind of carriage returns or anything else. Like you can just run off the edge and it will just do nothing. And then you got your clear commands, the set cursor idea, how to get the data converted, and then we saw that there was this weird awkward way to do decimal data. Again, if you can figure out a cleaner way to do this, I'll give you some bonus points. And basically that is going to mark the end of what we're going to talk about with the LCD screen. Now, as I said, I'm going to post the API for the MPL 115A2 because what you can do, and I'm going to have this maybe as just kind of something if you want to practice on something, is that you can have it so that you can display then, you can hook up both devices at the same time on the I2C and have it display both the temperature and pressure on it. So, alright, so that will make it the end of this video.